Hey, what's up, guys? This is let's see. This is going to be the data types getting started section. So from the Elixir Getting Started guide, we're going to go through the data types section. I'm actually pretty excited. Just the introduction video to this live stream series has gotten a lot of views. So I think I think this is going to be a popular live stream event, and that's going to be a lot of fun. So what's up, everyone? My one viewer at the moment. All right, I am going to go ahead and get started, and we're going to leave off where, or start off where we left off, and that is on, if we go to elixirlang.org and we go to the guides, and we did the introduction at the beginning of the week, and now we're going to do basic types. So in this chapter, we will learn about Elixir basic types. That's integers, floats, booleans, atoms, and strings. Other data types such as lists and tuples will be explored in the next chapter. All right, so if you see this Elixir shell example, we're not going to pull up the terminal quite yet, but you'll see that, 1 is an integer, obviously. And then you'll see this hexadecimal value, which is also an integer. So if we type this in as a hexadecimal, and we'll go more into detail how hexadecimals and binaries and all that stuff is calculated, just to kind of make sure we touch on the basics. But this will output as an integer if you enter this. And then a float is a decimal value, a decimal number. And then a Boolean is true or false. And an atom is essentially a string, but with a colon in front of it. But it can be used for like keys and other like constants and variable names and things like that. What's up, black type? I think that's Connie, right, Connie? Is that you? And then we have our list and our tuples. So let's go into our basic arithmetic, and now we'll open up our terminal. So I'm going to go ahead and say terminal. Where is my terminal? What screen are you hiding on? Oh, I have it open in another window. All right, so terminal, there we go. I'll make this a little bigger for us. The one and only Connie, my man. All right, let's go ahead and start up our IEX shell. And so let's see, let's try to show two things on the screen at once. So basic arithmetic, we kind of went over this in the introduction. So you can do simple things like 1 plus 2, we'll get 3. 5 times 5, we'll get 25. And 10 divided by 2. All right. And so now you should notice that 10 divided by 2 returned a float. So it returned us 5.0 instead of an integer of 5. And this is expected. In Elixir, the operator, I guess we'll call it / always returns a float. So if you want to do integer division, you have to use the division and the remainder. So you can invoke the div function and the remainder functions. So we can do things like this. We can do div, and then we can pass in 10 divided by 2, and it will return 5 as an integer. And you can also call functions without the parentheses, so we can do 10 and 2 and we get 5. And then you can do things like remainder, where we can pass in 10. And then this is basically, we're dividing by 3, but it's telling us the remainder instead of like a float value. So 3 goes into 10 3 times, which would be 9, and then we have a remainder of 1. So that is that. And then you'll notice that Elixir allows you to drop the parentheses, which I just said, when invoking functions that expect 1 or more arguments. This feature gives a cleaner syntax when writing declarations and control flow constructs. However, Elixir developers generally prefer to use parentheses. That's true. I prefer to use parentheses. Elixir also supports shortcut notations for entering binary, octal, and hexadecimal numbers. So we can do things like, oh, there we go. So if we type in something, so for a binary, it's always going to be like a 0B and then the value. So if we do 1010, we get 10 back. And what's important to know about binary is it's base 2. Here I have a little drawing program. So it's base 2, which what it means is it can either be a 0 or a 1. And the way that these values work, so I forgot what binary we just put in. So if we have 10, which is, whoops. So, sorry, my iPad disconnected. I'm going to use it as like a drawing tablet. So if we have 1010, which is 10, we have 1010. And this is equal to the integer 10. So when it's base 2, the way to look at this is you have 2 to the 0 power, which is a value of 1. And then we have 2 to the 1 power, which is the value of 2. And it goes on and on. So 2 to the 2nd power, you get 4. And then 2 to the 3rd power would be 8. So whichever bits are on, so we have our 1010. So we have a value of 8 and a value of 2. So 8 plus 2 equals 10. And so that's how binary works, okay? Pretty simple. And then we have, they show us an octal decimal value here as well, or octal, I guess would just be the name. And so you see these a little less often, but it's the same thing, but it's instead of base 2, like binary, it's base 8. So if we pull up our little drawing board again, what was the value? We should type that in. Sorry, guys. I'm all over the place. So we have this octal 777. And if we do octal 777 in our IEX, in our Elixir shell here. So let's see, 0, for octal, and then the value 777. We get 511 back as an integer, right? So if we have our octal value, we have 7, 7, 7, and that equals 511. And also, I'm sorry, my handwriting's horrible. I'm a lefty, and you know, it just never developed for me. So we have this, and this is now, so this is base 8. So it's the same concept as we did for binary. So we have now 8 to the 0, which is 1. And then we have 8 to the 1st power, which is the value of 8. And then you just keep going. And then you have 8 to the 2nd, which is 64. Math is difficult. And then, so what you would do here is you get 7 times 8. Wait, no, sorry guys. 7 times 64. Yes, 7 times 64, ignore me. So we have 7 times 64, and then we have plus 7 times 8. And then we have plus 7 times 1. And you add that all together, and we get 511. So that's how octal works. And then hexadecimal is a little different because we get letters involved. So if we look at this 0 or this 1F value, and we put that in, so I forgot what it was already. So if we do 0, 0x for hexadecimal, 0x, and then we have our 1f, we get 31 back. Okay? And so this is base 16. So same concept as octal. So we have 1f. And one thing to note here is, so for hexadecimal, you have values of 0 to 9. And then you have A through F after you get through 9. And basically A is 10 and F is 15. So we have the values of 0 to 15 at our disposal. Okay, so for 1F, we're going to have our base 16. So we have 16 to the 0, we get our 1 back, and then we have our 16 to the 1, and we get 16 back. And then it works the same way, so we get 16 times 1 plus F, which is 15. So 15 times 1 is 1, because that's the position it's in. And then, oh my gosh, my pen's not working. And then this is our value of 31. So that's how, a quick overview of those things work. And we'll clear that out. And let's go back to the documentation. And let me see if we have anyone talking. What's poppin', Jacob? Not much. Man, you made love Elixir and ditch Golang. That's a good choice. You definitely should love Elixir. You know what I just noticed? My chat window is not showing the chats. What is going on? That's strange. Is it working for you guys? Can you see your chats on the screen? That's a bummer. Well, I guess I'll just have to talk to you guys. I don't know what's going on. Dang. All right. Let me, that is super lame. Oh, well, I'm going to have to troubleshoot this later. We'll just turn it off so it doesn't look sad, like no one's talking to me. That's too bad. What's up, Mike? Manmu Han. I don't know. I probably butchered that. Hussein. It's good to see you guys. All right, so going on, now that you kind of understand how binary, octal, and hexadecimal numbers work, float numbers require a dot followed by at least one digit, and they also support E for scientific notation. So that is kind of cool. Let's pull that up. So this is a float, and what did they show us? So this is also a float, and you can do -10, and it just spits it out the same way that we wrote it. And let me draw again. So if we have 1.0 e to the -10, this is the same as writing 1 times 10 to the -10th. So basically, I don't really want to count, but we'd have like 10 zeros here and a 1. And that is how you would convert the scientific notation. But obviously, I know that's not 10 zeros. All right, so the Elixir shell, this notation is supported as a float. And then floats in Elixir are 64-bit precision. You can invoke the round function to get to the closest integer to a given float, or the truncate function to get the integer part of the float. And what that looks like is if we pull up our shell again, if we say round and then we pass in this number of 3.58, we get 4 back. So it's rounding to the nearest integer. And since 5 is, it's rounding up, so it's rounding us to 4. And then if we use the function truncate and do 3.58, it's just going to cut off the 0.58 and return 3. So it's going to just return the integer. It's just cutting off the decimals, okay? And then finally, we can work with different data types. We will learn Elixir provides several predicate functions to check for the type of a value. So for example, the is integer can be used to check if a value is an integer or not. All right, so let's try that out. I'm going to clear this to bring things to the top. So we can do this nice thing, like we can say is integer, and we can pass in a 1, and we get a Boolean back, so true, this is an integer. And then if we say is integer and pass in a float, so 2.0, it's false because it's not an integer. So you can also use is float or is number to check too. So we could say is float and pass in 2.0 and we'll get our true back. And we can also say is number and we can pass in 2.0, get true back. We can also say is number and pass in an integer and get true back. So that can be pretty handy. And so identifying functions and documentation. Before we move on to the next data type, let's talk about how Elixir identifies functions. Functions in Elixir are identified by both their name and their arity. The arity of a function describes the number of arguments that the function takes. So from this point on, we will use both the function name and its arity to describe functions throughout the documentation. So like as you saw the truncate function, we passed in 1 argument. So when you would be talking about this argument, they would be of arity 1, and that's what the /1 means. So it identifies the function trunc and it takes 1 argument. Where if you see trunc /2, this identifies a different non-existent function that would take the same name but has the arity of 2, which would mean it takes 2 arguments. We can also use the syntax to access documentation. The Elixir shell defines the h function, which can be used to access documentation for any function. So if we type in, let's pull up our shell again. So if we type in h and we want to know all about our trunc function of arity 1, it will give us our definition back. So it goes through. It's so like we know that it returns an integer, part of the number. It's allowed in guard tests, okay? And then it gives us examples of how it works. So using h is a nice way to get the definition of functions if you want to get a little more information out of how they work and how you can use them. All right. Where did I just leave off now? Okay, h. So h trunc works because it's defined. We kind of already did this. It's defined in the kernel module. So it's, okay, all functions in the kernel module are automatically imported into our namespace. So that's why we can just access trunc without saying kernel.trunc. Most often, you will also include the module name when looking up documentation for a function. So since the kernel module is automatically included, we don't have to include the module name, but we still can. But like if you were looking up definitions to maybe a function that you wrote in your module, you would have to include the module name followed by the function name. So you can use the module plus function to look up anything, including operators. So there you go. Let's see, try h kernel Okay, so we can try this on the plus operator. Let's do it. If the guide tells us to do it, we should do it. All right, I'm going to clear again so we can see what we're doing. So if I say h kernel dot plus arity 2, look at that. So it shows us that this is an arithmetic addition operator, and we can do an integer plus integer and get an integer back. We can do a float plus float, get a float back. We can do an integer plus float, and we get a float value back. You can do a float plus integer and get a float back. So that's pretty cool. You can dive into all these functions and know all the good stuff. All right, man, I love this. There's so many people chatting, and my stupid chat window is broken. After this series of introduction to Elixir, you should do the same for Phoenix. Not a bad idea, Sasha. I like that. How to start writing something fresh in the Elixir shell without closing. What I don't know what you mean by fresh. Like, you can recompile modules. You can recompile your project. You can, I'm not sure what you're asking though. How can I list the functions of a module? So that's a good, you're testing my memory here. We can type in H for help. We can just do help, and then we can look through everything that we have here. So you can see all the functions and exports using the exports. All right, so we can do that. So let's say exports kernel. There you go. You see all the functions available to us in the kernel. I'm learning details. I skipped learning Elixir the first time. You can't skip learning something if you're learning something. I feel like a lot of people shy away from reading through documentation. So that's kind of like why I thought it'd be fun. Like, why not just read documentation and everyone can hang out and we can chat about it? Let's say I wrote something garbage in plain terminal. Do we do Control C to start writing something fresh? Well, like, I'm in the Elixir shell right now, and like I can write, I can write a function like, so def add, and it can take a parameter. So it could take, I forget, what are the variables called when you add, like addend? I don't know, addend. Addend. I'm probably butchering this, so don't roast me. So you can do multi-line things, and then I could say like added in plus added in 2, and then that'll return, and I can hit end. Oops, what did I do wrong? Oh, it has to be in a module. So I'm too lazy, but you can do that. Like, I could do def module and like create my own module and then put that function in. But trial and error is the way to go. Trial and error is pretty important. You can do kernel and press tab. Oh, okay. Like, here, let's try that. Kernel dot tab. There you go. So you can see all the arithmetic operators there. And then you can press tab to see the 165 more things. So that's cool. I actually don't think I knew that one. I think I only knew exports. See? So we're learning stuff together here. Thanks, Mike. All right, let's go back to what we were doing. I kind of forgot. All right, so booleans and nil. Wait, I think that's, oh, here, wait. Without arguments displays documentation for helpers, which is H. Okay, yeah, we kind of went into that. All right, so booleans and nil. Elixir supports true and false as booleans. So whoops, what did I just do? All right, so we can do, let's see. So true, if we type in true here, it's true. If we say true equals false, it's false. So there's that. So Elixir provides 3 Boolean operators. We get or with the arity of 2, we get and arity of 2, and not arity of 1. So these operators are strict in the sense that they expect something that evaluates to a Boolean. So that's true or false as their first argument. So that's why, so we can say true and false, or true and true is true. And then we can say false or is Boolean true, and we get true back. So let's play around with that a little bit. So if we say true and true, that's true. But like if we said true and false, that's going to be false. And then if we say false or is Boolean true, so obviously true is a Boolean, and we get true back because just one of these values would have to be true for or, and then and they both have to be true to get true back. Yeah. And then you can provide non-Booleans with raise as an exception. So we can do things like 1 and true. And so if we go back up here, I don't want to breeze over this. So it expects a Boolean as the first argument, right? So if we say 1 and true, we're going to get this error back. So let's go ahead and see if that happens. So if I say 1 and true, okay, so it expected a Boolean on the left side of and it got 1 instead. So we have to have a Boolean operator to the left. All right, so or and and are shortcut or short circuit operators. So they only execute the right side if the left side is not enough to determine the result. So that's important to know. So if we do their example here and we say false and then let's raise, this error will never be raised. We get false because the left side was evaluated, or it determined a result for us. And then same with putting true or raise, this error will never be raised. All right, so true, because it's going off the left side evaluation. So Elixir also provides the concept of nil to indicate the absence of a value, and a set of logical operators that also manipulate nil. So we have or, which is I always forget the name of this damn thing. I call it the pipe, but it's not a pipe. Well, anyways, you have your or double pipe arity 2, and then you have your and then you have your not arity 1. So for these operators, you get false and nil, and they're considered falsy. So all values are considered, all other values, if it's not false or nil, are truthy. So integers are true, and so on. Let's see, I'm sure no one corrected me on this. What is this operator called, guys? What is that keystroke called? It's not a pipe. I can't remember. My brain, when the pressure's on, we're live, it doesn't want to work. But anyways, let's go through this example of like how or works. Let's pull up our terminal. And so if we say 1 and then we'd say or true, we get 1 back because 1 is actually a truthy statement. So it's going to return, it's evaluating just the left side again. And then so if we did false or 11, we'll get 11 back because 11 is true and it's an or statement, right? And then so and works a little differently. If it was nil and 13, we get nil back because nil is false essentially. So they would both have to be true. So if we did true and 13, then we get our 13 value back. Okay, so that's how that would work. And then the not value, if you do, explanation, true, you get the opposite. This is the not version. So this is false. And then same if we did that with a 1, it would be a false value. And then that to nil is true because it's the opposite of nil, which is true. All right, cool. Guys, this is kind of fun to read all this, isn't it? Let's see, do we have any comments? Not any new ones. All right, so moving on to atoms. An atom is a constant whose value is its own name. So some other languages call these symbols. They are often useful for to enumerate over distinct values, such as apple, orange, watermelon. Atoms are equal if their names are equal. So apple equals apple. Apple does not equal orange. So let's pull up our shell again. And if we say apple equals apple, that's true. If we say apple equals orange, that's not true. False. All right. So often they are used to express the state of an operation by using values such as the atom OK and the atom air. So the booleans true and false are also atoms. So true is equal to the atom true. So if we go back to our shell here, we can actually see that this boolean, this is a boolean, okay? This is equal to the boolean true. And then we can also do is atom, and we can just pass in false, and it is an atom, so we get true. And then we can also say is boolean, and pass in an atom of false, and that's true. So atoms, booleans are atoms under the hood. All right. So let's see. Yeah, Elixir allows you to skip the leading colon for atoms, false, true, and nil. So nil is also included in that. Under the hood, false, true, and nil are atoms. All right, strings in Elixir are delimited by double quotes. They are encoded in UTF-8. And something you should note, if you're running Windows, there's a chance your terminal does not use UTF-8 by default. You can change the encoding of your current session by running chcp 65001 before entering the IEX shell. So we kind of went over this in the intro, but we can just do hello, and that is a string. And you can also concatenate two strings with the concatenation operator arity2. And what that would look like, we went over this in the intro video, but it doesn't hurt doing it again. We can say hello and then concatenation operator, which this is a function with an arity of 2. So it's taking the left-hand side, hello, and the right-hand side, which we'll say, we need a space in that, or hello world, and then it returns our combined string. All right. So Elixir also supports string interpolation. Then what that means is you can set a variable, and then you can display that variable inside of a string using the hashtag and then opening and closing brackets, curly braces. So if we just create a variable named string, and we'll set it equal to the word world. All right, hit enter. And now if we type in string, which is our variable name, we get the value world back. All right, so that's pretty cool. And now to do string interpolation, we can just say double quotes. We can say hello, space, and then to use our variable, the hashtag opening and closing curly braces, and then just the name of our variable in between those curly braces. And then we can continue on with whatever string we're typing. So exclamation point, and then double quotes to close that off. And when I hit enter, we'll get hello world back. So that's string interpolation. And now let's see, string concatenation requires both sides to be strings, but interpolation supports any data type that may be converted to a string. So this is pretty cool to know. All right, so if we go back to our shell, we can set a variable number equal to an integer of 42, and we can say I am, and then we can do our interpolation. So we can pass in our variable number and years old and close that off. And when we hit enter, our integer 42 was automatically converted to a string. So that's pretty cool. Strings can have line breaks in them, and that's the \n, and you can introduce them using the escape sequence. So the line break, so I guess the \n is an escape sequence, which is a line break. And so let's see, let's play around with this. Whoops. Terminal, there we go. Sometimes I struggle with the keyboard. So we can do multiple line strings. So if I just started a string and nothing closes it off and I hit enter, it's waiting for the rest. It wants me to close the double quotations off, and then you'll see that it puts the line break, the \n in there, and that's important to know. And if we did it all on one line, so hello, and then we could do \n again and say world, it returns it the same way. And then if we wanted this to display nicer for us, we can actually use, we can print the string using ioputs function. And this is from the IO module. So we can do ioputs. And if I say hello, \n world and close off those parentheses, when I hit enter, the ioputs will do the line break for us, and we don't see the \n anymore. And then it'll say, do you notice that ioputs arity1 function returns the atom OK after printing? So it's letting us know that that function successfully was called, and it returned the atom OK for us. All right, can you interpolate an atom into a string? Yes, you can. What makes, are we going to also look at sigils in this one? I don't think we're touching on that yet. That is way down here. In this series we will, but not today. We're just going over basic types in the Getting Started guide. So we're doing, let's see, basic arithmetic, identifying functions, booleans, atoms, strings, and structural comparisons. Let's see, what makes the concatenation operator infix? Generally, we specify the module, then dot, followed by the function. I'm not sure what you're asking. Sorry, man. Can you interpolate an atom into a string? Yes. So strings and atoms are the same thing, but so you can do, let's see, I believe, I'm trying to think. If we do string to atom, we can do like hello, and we get that back. And we can also say atom to string, and we can say hello and get a string back. Oh, I see what you're asking. So you want to know if we can interpolate it. Let's try. I'm not sure. So let's say we have a variable called ratom, and we'll say Elixir mentor. Okay, so we have our atom, and we'll say hello, and we'll do this. And I believe this is going to work because it can take any data type that can be converted to a string. So we'll do that and then hit enter, and look at that. It automatically converted it to a string for us. So the answer is yes. All right, let's see. Where did I leave off? All right, so strings in Elixir are represented internally by contiguous sequences of bytes known as binaries. So if we use the function isBinary on a string, we're going to get true back. We can also get the number of bytes in a string. All right, let's do it. So isBinary, hello. Oops, I need to finish that double quote. All right, so that is true. And then we can also say byte size and pass in hello, and we get 5 back. So each character is a byte. And we can also do, let's see, notice the number of bytes in that string is 6, even though it has 5 graphemes. I think that's how you say it. I don't know. But it's because we have this little accent above the O in this one, and I didn't do that. And that's because, okay, yeah, it tells us right here that the little accent is 2 bytes represented in the UTF-8. And we can get the actual length of the string by using string.length arity 1. Whoops, I didn't mean to do that. What's nice, though, is in the documentation and the Getting Started guide, you can click on these things and go to the actual documentation of that function. So good to know, right? So we can also do string.length. And obviously, I didn't use the accent, so it's going to be the same thing. So string.length. And when we pass in hello, we're going to get the length 5 as well. All right. And the string module contains a bunch of functions that operate on strings as defined in the Unicode standard. So we can do string.upcase. And let's try that. So string.upcase is going to put everything capital. So Elixir mentor, and there we go. And if we wanted to see more, we can just do string.tab and tab again, and we can see all the functions available to us in the string module. So pretty cool, worth playing around with, always fun to do. All right, structural comparison. Elixir also provides equal to, not equal to, less than or equal to, greater than, equal to, less than, and greater than comparison operators. So we can compare numbers. All right, let's start comparing numbers. So we can say 1 equals 1, we get true back. We can say 1 is not equal to 2, we get true back. And we can say 1 is less than 2, and we get true back. And so you can also use these operators to compare atoms, strings, and booleans, so on. So as long as it's the same type that you're comparing, so if we say foo equals foo, that's true. If we say foo equals bar, that's false because they're not equal. And it works for atoms too. So atom equals atom, it's true. All right. And then integer and floats compare the same if they have the same value. So, all right, this is kind of a cool section. It's good to know. So we can compare the values. So if we say 1 equals 1.0, we get true back. And then 1 equals 2.0, we get false back. And then obviously 1 equals 1, right? However, you can use the strict comparison operator, which is 3 equal signs or a not equal, and then followed by 2 equal signs. So if you want to distinguish between integers and floats, this is the way you would do it. So if we wanted, like, obviously, what if we wanted to know if 1 was equal to, like, 1 is an integer equals 1 is a float, but we wanted false back? We can just do 1 equals 1.0, and then we'll get false. So this is the strict comparison operator. And it's good to know, right? So we could also do the not equal. So if we did 1.0 not equal, equal, boom, that is false. But if we did like the integer, that is true. So the comparison operators in Elixir can compare across any data type. We say these operators perform structural comparison, And so for more information, you can read our documentation on structural versus semantic comparisons. All right, so let's click on that. Look at this. You can just go into a deep dive of how structural comparison works, which maybe we should do this. We'll do this in another video though. I like that. So Elixir also provides data types for expressing collections such as lists and tuples, which we'll learn next. When we talk about concurrency and fault tolerance via processes, we will also discuss ports, PIDs, and references, but that will come in later chapters. So let's move forward. All right, cool. So that is basic data types. And I think that was a lot of fun. And in the next video, we'll go into the next section, which is lists and tuples. And yeah, let's see. Let me catch up on some questions here. We are able to do kernel.+1 and 2. I wanted to know the mechanism that allows us to write it the second way. Macros. So basically meta programming. Basically every function that we use is a macro, and that's how that would work. And I'll probably eventually do some macro videos for YouTube. I do have a macro section that I'm working on currently in my course that is my paid course, but yeah, that's how that works. Yeah, this was a lot of fun, and I really appreciate you guys being so active and asking questions. And I'm bummed that all the chats weren't showing up, so I had to figure that one out. But something broke, but that's okay. Yeah, this was a lot of fun, guys. Thank you so much for being here, and I'll see you in the next one. I'm going to plan the next live stream for lists and tuples to be on Monday. Same time, 1:30 p.m. Mountain Standard Time. And yeah, this was awesome, guys. I really appreciate it, and I love that so many people tuned in. So I will see you guys in the next one. Enjoying the video? Show some love with a like and hit subscribe to stay updated. To support me and keep the content free, click join for memberships or pick up a course at elixirmentor.com and get free access to my private community. Let's jump back in.